we look at the improved DHCP mechanism that we have introduced in this feature to help our customers. We have now improved the state represented in Address Manager to accurately reflect what's happening in the DHCP server and what the Address Manager believes is the correct state. So how does it work? Users have the ability to process and mark the abandoned leases as abandoned in Address Manager. Users will have the ability to edit, move, delete, or in fact change the abandoned state to a DHCP reserved, or in simple static state. Let's look at how does an address manager handle abandoned leases in Integrity 9.3. One of the scenario of having an abandoned lease would be clients decline leases. In that case, lease files get updated with the abandoned state, and lease file watcher send a notification to address manager and its database gets updated. If an admin deletes an abandoned IP in address manager, it sends the free host IP command to BDDS. Then the binding state in dhcpd.lease file gets updated with next binding state set to free. Therefore, the specific IP freed from dhcpd.lease file. And after that, lease file watcher picks up the changes in the lease file and triggers an address manager notification of type free. Now let's look at how does refreshing DHCP states work. Upon getting the refresh DHCP states request from an address manager, BDDS sends lease states to address manager based on lease states that are recorded in the lease file watcher process, which is considered to be the source of truth for DHCP lease states. And for each DHCP lease refresh, BDDS sends all lease states in a single transmission. Keep in mind that lease states retrieved from individual BDDS to BAM get processed by the same logic as utilized by DHCP notification. In these demos, we will be looking at how to handle abandoned leases in Address Manager and how to refresh DHCP lease states in Address Manager to get a true picture of DHCP leases from BDDS. In this demo 1, we are going to look at how to handle abandoned leases in Address Manager, including how to edit an abandoned IP, move, delete, or change an abandoned state to a targeted state such as static, reserved, or DHCP reserved state. To illustrate DHCP abandoned leases, we will be using a DHCP client called DHTest that will allow us to send a request for an IP to our BDDS server, and then the client will decline the request once it receives an IP from the BDDS server. We'll be also showing abandoned leases in DHCP utilization from reporting perspective. In this demo on how to administer DHCP abandoned leases, we have a /24 network with DHCP range from 6 to 15. And under the servers tab, we have our primary BDDS server, which is 21. On the top right corner, we have our DHCP client, and on the bottom right, we have SSH to our BDDS server to check lease file. Now, using our DHCP client, let's send a DHCP discover to our BDDS server. And once we get an IP, our DHCP client will decline it. Now that we did that, let's refresh the network page. We can do so by click on the refresh DHCP states in the network drop-down list. We'll discuss the refresh DHCP states in details in our demo 2. Now, as you can see, 6 is in DHCP abandoned state because 6 is the first IP in our DHCP range. Now, if you look at the lease file, you can see that 6 is indeed in abandoned state. Now, if you click on the drop-down list of an abandoned IP, you will see customers have 4 options: edit, move, change IP state, or delete. Now, let's edit this IP. Let's put a name demo 1. Now, let's move 6 to a different location. We are going to put 12. 12 is in our DHCP range, so it will become static. As you can see, it's static. Now, to demonstrate the change IP state option of an abandoned IP, we are going to send another DHCP discover to our BDD server using our DHCP client. And obviously, we'll decline it so that the IP become abandoned. Again, let's refresh the network page. And once we refresh it, we can see that now 7 is in DHCP abandoned state. And we can also verify that by looking at the list file. The binding state is in abandoned. Now let's change IP state for 7 to something else. You can select static, reserve, or DHCP reserve as a target state. For this purpose, we are just going to keep it static, and we are going to put a MAC address. Once you update it, the MAC address will be associated with the IP. Now, again, let's send another DHCP discover to our BDD server to get another abandoned IP in our address manager. And we are going to refresh the page one more time. And 8 is now in DHCP abandoned. Now let's delete it. Once you delete the IP, it will become DHCP free. The page is not refreshed, that's why it's not showing, but let's look at the list file. And as you can see in the list file, the binding state is DHCP free. Now let's refresh the page one more time, and it's being reflected in the network page. 8 is in DHCP free state. Now, for the demonstration perspective, and because you have to show how DHCP are being utilized in a reporting, we are going to create some abandoned IPs using our DHCP client. Let's look at some of the DHCP utilization reports. If you look at the block network DHCP utilization, it shows that DHCP abandoned leases utilization is 2% of the network. But if you look at the DHCP pool utilization report, we can see that the utilization is 50% because we have a very small DHCP range of 10 IPs only. Let's verify this utilization report by looking at the network usage bar and DHCP range usage bar. Here, the network level, DHCP abandoned lease usage is 2%, and at the DHCP range level, you can see the utilization is 50% as we have seen in the report. A quick recap on what we have seen on the demo one. We have used a DHCP client to send DHCP discoverers on the network to get IPs from our BDDS. Then the client declined those IPs which made them abandoned. After that, we have edited the name of an abandoned address in Address Manager, followed by moving an abandoned address to a new location. And then we have deleted an abandoned address to make it free. We also changed the state of an abandoned address to static. And finally, we have looked at some DHCP utilization reports that includes abandoned leases. In this demo too, we are going to look at how our customers can refresh their DHCP lease states from a network level and from a server level right from their address manager interface to get a true picture of their DHCP lease states. In our demo on how to refresh DHCP lease states, we have created two networks under a /16 block. Under the first network, we have created a DHCP range from .2 to .5 And also we have created a DHCP deployment roles where BDDS1 is our primary and BDDS2 is our secondary. Similarly, under the second network, we have created another DHCP range from .2 to .5 and another DHCP deployment roles where BDDS1 is our primary and BDDS2 is our secondary. Now, we are going to turn off the notification from our BDDS server so that our address manager doesn't get updated for any lease. As you can see here now, there are no lease information in this network. Now, we have prepared DHCP lease files that we want to manually update on both BDDS servers. The left one is the primary and the right one is for the secondary. Since both BDDS servers will have the lease information for all the IP addresses, we put the top two entries for the first network and the bottom two entries for the second network. We have also set parameter request list for .2 in our primary server, but not for the secondary. Similarly, we have put set parameter request list for .3 on the secondary, but not on the primary. Let's update the both list files to our primary and secondary VDD servers manually. Here we are updating the list file 1.txt to our primary and list file 2.txt to our secondary BDDS, which is .22. Now that we have updated the list files, BDDS servers will start sending out notifications. Since we have logged the notifications, we wouldn't see any list information updated on Address Manager interface. As you can see, there is no list information. Let's click on Refresh DHCP States from the Network drop-down list. Once you click on it, Address Manager will ask you for a confirmation. After the confirmation, the refresh process will start. As we clicked very quickly, the page is not refreshed yet, but the details page shows that the list refresh is pending and the last successful refresh is none because this is the first time we are refreshing this network. And now that we refresh the page, we can see the list information. Here's the list information of our both IPs, including the parameter request list. When we added the list information manually, the parameter request list for .3 was available on the secondary, but not on the primary, which means Address Manager got information from both BDDS servers. In the event list, it shows that DHCP states refresh was started and successful with the appropriate timestamp and messaging. If you click on the event ID, it will show you the message and the same timestamp. The next part of this demo is to look at how to refresh networks from a server level. Instead of refreshing networks one by one, customers can refresh all networks of a server at once. In our scenario, if you click on BDDS1 server drop-down list, and then again, if you click on refresh DHCP states, it will refresh the networks that we have created earlier. Now, before you start refreshing from a server level, let's look at our second network that we have created earlier, and let's make sure that the network is not refreshed yet. Now, let's go back to the server level and click on the refresh DHCP states from the server drop-down list. Once you click on it, it will show the confirmation message by saying that the server refresh process may take some time, depends on the size of the networks, and event list will show the details of the status of the refresh. Now, let's have a look at event list. If you click on event list, it shows that our BDDS 1 is refreshed successfully. It also shows a message with an appropriate timestamp. If you click on any of the event ID, it will show the exact timestamp and the message. Now, let's go back to the second network. It has been refreshed with list information, including the parameter request list that we have added manually earlier. And now in the details page, it shows that there is no pending refresh and the last successful refresh. Again, a quick recap on what we have seen in the demo 2. We have seen that with this feature in Integrity 9.3, our customers will have the ability to refresh DHCP leases from a network level or from a server level. We have also seen from the network level refresh, customers will have the ability to check if there is any pending refresh in case of multiple DHCP lease refreshes for multiple networks have been triggered, and date and time of the last successful lease refresh.